Today's workshop is going to be about prototype mold making. This is mold making that happens before you get into really high-end production. It happens when you want to copy, duplicate objects that you have made or found or modified, and they're just the way you want them, and you just want them in a different material, or you want 10 of them. What we're going to do is over the course of several workshops, we're going to create a silicone rubber mold, which is soft rubber, and in two parts, so the first side and the second side, and then we're going to pour a urethane part. We're going to create a urethane part by pouring liquid urethane into the completed mold to get a hard plastic part. So that's what we're up to. The reasons for using prototype tooling is it's a very fast and relatively cheap way to get multiple parts of an object that you've gotten to where you like it. So if you've been working on, let's say you've got a widget like this, you've got a remote control for your car that you're designing for somebody, and you've got it just where you want it, you printed it out, or maybe you machined it, you had to make some changes to it, maybe you used your Bondo and you added some stripes, or you added a hole, or you filled in a hole, or you took the key fob thing from this side and put it on that side, and now you want to test it, now you want a half dozen of these things. You need to get some way to turn one good part into multiple good parts, and that's where prototype mold making comes in. So there are many different paths to doing this, lots of different choices of materials, whether we go with a soft rubber tool like we're doing, or you can go with a hard urethane tool if you'd like, depending on the material that you're going to create the part in. One's a better choice than the other. So we're going to investigate this one avenue of silicone molds and hard plastic parts. So why are we learning all this? Well, I'm going to bet that many of you will have to purchase injection molded parts and injection molding tooling at some point in your life. And a smaller set of you will actually probably design some of those tools. And all of you are going to be using parts every day that have been made with injection molding or other molding processes. This is a way to introduce you to the concept of what works for molding and what does not work. The prototype molding process has some rules that carry over into the world of production steel tooling. And I'll point those out when we come across them. And it's just generally one more step in getting your education where it needs to be, so that you can have as wide a library in your mind of construction techniques as possible. So the first rule that you need to know about mold making is about draft angle. I'm going to go to the board and I'm going to demonstrate what draft angle is. Let's say you wanted to make that part. You could do that with a mold if you had one half of the mold down here, the other half of the mold up here. This part will fall out of the mold because it has such a high draft angle. By contrast, this part will have a great deal of trouble getting out of its mold because there is no angle. It's parallel sides. It doesn't want to come out, and you'll fight it, and it's going to break. So we want something between this extreme draft angle and this complete lack of draft angle. In injection molding, that's usually just 3 or 4 degrees. With the silicone tooling that we're using, we can get away with 0 degrees draft, and sometimes we can also get away with what's called jumping apart. Whereas if you have a part that would otherwise be captured inside the mold, you can bend the mold and pull it out, because we can do that with a soft silicone mold. Bending a steel mold to get a part out is not going to work. So it'll work that's one of the things that'll work in prototyping, but not in production. Where are we going here? It's also possible in the prototype mold making world to have a mold that's partly a rigid material, like a urethane or steel or aluminum, and then the other half can be flexible rubber, either urethane rubber or silicone rubber. So that would be a hybrid, and that can also exist. So our strategy going forward for this mold, and we're going to be molding parts just like this. This is just an off-the-shelf remote control for a car. This side has holes, this side does not. Both have detail and bosses and walls on the inside. We're going to make a mold of the first side for this side of the mold, and then we're going to take and we'll have the mold material. We'll pull this piece off. We'll prepare the tool, and we'll pour the second half. Then we'll have a two-piece rubber mold. We'll peel it apart. We'll take out the rubber. We'll put the thing back together, and we'll have a cavity inside these two pieces that's exactly the shape that we want to copy. So before we go and we pour all those things, we have to figure out how we're going to get material in and out of our empty mold. Okay, we're going to do that with something called gates and sprues and vents. Okay, going back to the board here. If we wanted to pour this part, let's say it's solid plastic. Okay, we would probably consider pouring this thing upside down from where it is, and we would have, before we pour it this side, we would prepare it for one place to put material in and a tiny little vent to let air come out. When we turn it upside down, we pour our material in here and the air escapes, and we have a part that has as few bubbles as possible. That's our goal. So we have these square pieces of plastic. This is going to be our mold base. This is going to create our parting line. The parting line goes right there, and it separates the two parts of the mold. Hence the name parting line. So parting lines are not always just a flat plane. In this case, they will be. So we're going to use a bit of modeling clay that is suitable for use with our silicone mold making material, and we're going to squish it right on here to hold this in place. And then we're going to sculpt the clay around to give the part to fill in. We're going to fill in those holes, right? And there's an undercut on the bottom, where a reveal where the two pieces meet, and we're going to fill that in too, and we'll create a slightly modified parting line right along the base. So one of the tools we're using here is just a finishing nail that I've flattened out and ground into a little paddle shape because it's the right size for doing what we're doing. So we get a lump of clay. This stuff works better when it's a little bit warm. So we just sort of warm it up a little bit in our fingers. I want enough clay to fill in the bottom here, with to fill in the inside of that. The stickiness of the clay is going to hold this part to the base, and we're going to sculpt the clay into a little mold. And if you haven't already turned it to 2x speed, you might want to do that now. not trying to get it perfect. I'm trying to put a little bit more than I need all the way around. Some of you, like I said, will get the side with the windows, the little holes for buttons. Some of you will get the side that does not have that. And you can, if you come to workshop early enough, you get to choose which one you get. It's a little bit more challenging doing the windows, and I encourage you all to grab for the difficult ones. Okay, so I've got a little pencil mark on here to show me where the center is. I'm going to drop this more or less in center. And I'm just going to wiggle it right down, let the clay mush out wherever it wants to go. And that is on there pretty good. Now, of course, I have blobs of clay all over the place, and we're going to take a lot of that off to create the what we're looking for to do. So the reason why I've got clay all over this is because if I just left it sitting here and poured silicone on it, the silicone would go all the way through these and in here, and it would encapsulate the entire thing. Because we don't want to make a mold that way this time, we're filling in everything that we don't want to be part of this side of the mold, filling it in with clay. And that will that'll let us tell the silicone where we want it to go. So I'm going to take a lot of this clay right out, and I'm going to bring it down to the level here where that little radius is. You'll see it when you're here in workshop. This is one area where you want to spend a little extra time to get it as clean and neat as you can. Perfection is not a realistic goal, but it is a very good target to shoot for. And I've got a little bit of clay on the side, and I'll just make sure I clean that off too. All right, you can see how I've done these two. I'm going to continue to do these as well, but I'm going to do one side to show you what I have in mind here. I'm just going to take off the extra clay that I know I don't need. So right now we have an undercut over here. It's called an undercut. It goes underneath right here. So that would be a very difficult part to pull out if we allowed the mold to go around and capture the part in that way. So we're going to fill that in with clay and have the clay form a little ramp just like this. Okay, so now when I make a mold, everything that you see here, when I pour the silicone over here, that's what the mold material will see, and that will become the shape of the mold. So if I make an error, that error will appear in my mold. If I do a super good job, that super good job will appear in the mold, and therefore it will appear in every single part that I make. So I'm going to swing around the corner this way just to continue it. And we have to change gears a little bit over here. We do want to fill in underneath that. This is a skill that takes a while to acquire, so fear not if you are not doing this as easily as I'm doing it here. Okay, so this is not straight up and down. It's flared out just a little bit. That gives me my draft angle to ensure that the part will come out after we pour it in the hard urethane. There's a little bit more of an angle over here. You can see that. That's probably 15 degrees, which is plenty. We'll just cut it down a little bit. So when you get in here, you'll pick up your part, you'll pick up your white board, and you'll get a small fingerful of clay. You don't need a whole lot. And you'll get one of these little tools. And you will have a wonderful time becoming one with the clay, exercising your zen and your patience, and asking me for help whenever you need it. The next step for this is to plan how we're going to locate this half of the mold with the other half. We're going to do that using pins or rope. So if I put a pin right there with a little bit of draft on it, when we pour this side of the mold, that will become a cavity. When we flip the mold over and pour the other half, everything you see here in clay will be cast in silicone. So what the end result is, we will have this little finger coming into this side of the tool, and that will locate it, keep it from spinning. These are commonly called registration pins because they register the two pieces of the mold with each other. There's lots of different ways to do this. This is one way. You can also make you can pretend to be your 5-year-old self again and make little clay snakes like this and go around like that. That also creates an interlocking ridge between the two halves of the mold when they're complete. And because there is a little bit of undercut in here, the way I've currently got it, the two halves of the mold, because we're using soft material, those two halves will snap onto each other and hold the mold together. So that's not a bad thing to have happen. Okay, so what we've done is we've taken our part, we've put it on the mold board with some clay, and we've cleaned up the clay a little bit to create our desired parting line, parting surface. This clay here that I'm working now represents one part of the parting line. This is another, and here and here. These two haven't been worked yet. And all the way around is the parting surface. So in next steps will be to put a box around this. We're going to use round pipe. We're going to put the round pipe on there and fill this up, fill it with silicone and let the silicone cure and harden up and create one half of our mold. I've put in my clay, as you remember, from not that long ago. For me it was yesterday, for you it was just 10 seconds ago. We've got clay in all the holes and around the perimeter so that we're creating a parting line. We have this little snake of clay that goes all the way around the outside. That is going to help register the two halves of the mold. When they go together, it'll lock it tight. And a little bit of irregularity means it can only go together one way. And I put, just for fun, put my little dot of clay there with my name in it. That will show up in the mold so that I can tell that it's mine. I encourage you to mark yours at least in a similar way so that we can tell what's yours. Okay, so now we can go to, now we can back up a bit, the camera. This is a piece of PVC pipe, and I've cut it into a 50 millimeter length, okay? What we're gonna do with this is use it as a dam or as a wall for our mold. So we're gonna pour our mold making silicone into there. This is a very easy way to get a mold shape that we want Okay, if we absolutely had to have square or rectangular, then we'd just use straight stock and cut it and glue it. But we don't have those constraints here, so we're going to go round. So before I glue this on, I'm going to take just a little bit of petroleum jelly or Vaseline, and just a little bit really, and go all the way around the inside with it. Make sure to get as much of it as I can all the way around the inside, but don't get the edge or the outside surface, because we need to use that for glue. Okay, that glue has to stick to this. The Vaseline is here so that the silicone won't really grab onto this piece of pipe. It's not going to stick chemically, but it'll stick with enough suction so that it'll be hard to move it. And this will become obvious in the next step. So I'll explain it all a little bit better later. I'm putting this piece of pipe centered as I can get it, right on my mold board. I'm going to use good old hot glue gun. Okay, I'm going to just hot glue it on. You need to get a relatively good seal with the glue. You don't need to, you're not shipping it overseas. It doesn't need to have a pound of glue on it. Enough to make it watertight is enough. And you'll learn if you did it right when the silicone either dribbles out the bottom or doesn't. And that's not really fair, I know, but that's the way you'll learn. So you can see on the bottom here, there's a little bit of a gap. So that gets a little extra glue here. Silicone is fairly thick when it's in liquid form, kind of like honey. So it's not going to go through tiny cracks. But let's not learn the hard way how much of a crack is too big. Okay, there, that's good. Put the glue gun away, put away the petroleum jelly. Now I'm going to introduce you to our scale. We have several of these. We have a silicone rubber here. This is part A, and this is the catalyst, or the part B. In this case, there is a 10-to-1 mix ratio, 10 parts of this, 1 part of this, by weight. So we're using a scale to weigh them out. And I'm going to weigh it out in this cup. We're going to fill this. This is 2 inches, or about 50 millimeters tall, this tube, and we only need really half of that to make a decent mold. So I'm going to take a look, and I'm going to guess that if I mix this up to the little ridge here, I will have enough silicone to make a decent mold. So for your benefit, I'm facing everything over to you. Turn it on and put on our cup, and it weighs the cup at 15, is it on grams? Ounces, it's 0.15 ounces. I'm going to put it on to tare, okay? And because it's 10-to-1 ratio, the math is going to be relatively easy, and it doesn't matter whether you're in grams or ounces on this. I'm going to fill it up to about here with part A, and then I'm going to fill it up by weight with the catalyst to the part B. Then I'm going to stir it all up and pour it. And this is an easy enough exercise. I think most of you might actually spend most of your time waiting for somebody else to get through with the scale. Okay, I'm going to tare. When you hit tare, that word tare means that you're going to have the scale not count the weight of the object that you're measuring in, the cup or the paper towel. So that's the tare weight. You don't want that. You only want the weight of the product, the net weight. So we'll hit tare again, and here we are. Okay, so we're ready to go. I'm going to close that to keep it relatively clean. Come here. And this is, I will have to admit, the messy part, especially for the first person to pour out of a very full tub. Okay, I think I might have a little bit more than I need, but it's okay. That goes here. I'm going to clean this up a little bit. So you saw that I switched over and put my gloves on. This stuff is not necessarily toxic, but it is just super messy. And you don't want to have to clean it off or anything. So I put the cap on to keep it clean. I look over here and we are at 6.1 ounces. Am I reading that right, Ben? Yep. 6.1. So that means I want, hey, just for the sake of math, let's go into, we're going to go into grams, 173. So basically 10% of that is 17. So I'm going to hit tare again. And now we're at 0. And I'm going to just pour this in until it reads 17. And it's messy. I told you that before, it's messy. Is that 16? I'm trying to read upside down through a filthy lens here. There we go, now we're at 17, good. Okay, so these two parts should not be mixed until you are ready to stir them up. And meaning you don't want to accidentally put some of this into here because it will spoil the whole batch. So that's another way to say cleanliness is key with this kind of product and with this kind of project. If you start off messy, it never gets better. If you start off clean, you can keep it clean. It is, however, a skill that you'll need to learn. Not keeping clean, but keeping this stuff clean, because it's not necessarily an easy thing to do, but that's why we're doing it, so that you'll get exposure and you'll learn how to do it. I'm turning off my scale. I don't need it anymore. I'm going to put it over here. It's relatively clean now. Now I have my clear catalyst on top of my white silicone. Some silicones, indeed some two-part concoctions, whether they're molding compounds or silicones or urethanes, sometimes they give you two colors and you mix the colors up, and when you get to a third color, so the catalyst and the resin are different colors, and you know when they're mixed because you've achieved a uniform third color. We don't have that luxury here, so we are just going to mix until we are reasonably certain that we have mixed enough. And this is a tough one. These are really flimsy little cups. I'm going to get you guys better cups to mix with. So when you mix, you'll see I'm spinning all the way around the outside to get all the resin off the wall of the cup, because if you don't mix it thoroughly, it will still come out of the cup and go into your mold, even if it's not thoroughly mixed. And if you get some of this stuff that is not mixed and it winds up in your mold, it's going to be like this for the rest of the time. It's never going to cure. Some of it will, some of it's going to be like this, and it'll be a messy mess. It's just a sort of you'll have to start over because it won't be fixable. So the rule of thumb with this stuff is sort of mix it for a couple of minutes, scraping the wall the whole time. Some of you are probably wondering why on earth you're just sitting there spending your time watching somebody mix resin when you could be doing 10 other things. I get it. But this is one of those things where if you don't do it right, you won't get to go to the next step of the project with everybody else. You'll be a week behind, or at least a day behind. So just do it right. Cleanliness. Make sure it's all mixed up. Spend a little extra time. You're in no rush. Where you're going to go anyway. Okay? Just do it right. You will probably spend more time listening to me babble about it than actually mixing it yourself. So think of that as a good thing. Okay, so now I've got my resin mixed. I'm going to just clean off my mixing stick here. And I've got my mold. And I'm looking at it just to make sure that everything's a-okay, and I see a little spot where I need just a little bit more glue there, so I won't have to explain to you why I got drips coming down the outside of the mold. I think we're good. I'm burning my finger at the moment. That's good. Okay, so what I'm going to do, I don't want to trap air against the part. So I'm not going to just go blunk and dump this thing in, because you'll get air bubbles everywhere. Okay, I'm going to pour it in slowly, and in this case I'm going to use something like that to hold it so that I can pour to the deepest part of the tool, or the deepest part of the mold board. Pour in slowly, and the resin will rise up. When it's all full, I can drop it back down again. Why am I doing this? Because you can see, if you look in there, Ben, you can see that this the resin is slowly climbing up, and if I was to do it faster, the little wave of silicone would go and capture air, and then you would have air in the mold, and that is not good for parts, because you would have a bubble in the part. I can see some air in there already still that we might have to deal with, but the key here is pour slowly, pour evenly. I hope you guys are all on at least 2x by now, watching this at high speed. Now I've got most of it filled, so I'm just going to drop it down and let it level itself out. And we can see that it's starting to close in around the last bits of the part. I'm going to let it do that slowly. I'm going to keep my resin pour over to one side. That way I won't trap air, or I won't trap this air. There might be air over here trapping itself, but at least I won't get any of these bubbles coming out to go right where it's closing in. Okay, so now it's all filled. Now I can just fill this thing up. I want my mold to be relatively level so that I don't have a mold that's wedge shaped, where it's too low on this side, too high on that side. Okay, now silicone is relatively inert when it cures, so when it's cured I can peel it out of the cup and use the cup again. But if that doesn't work, like if there's a bunch of unmixed stuff, it's okay to throw it away, because it isn't going to mess up the water supply when it goes into the, it's not going to affect groundwater, basically. We've prepared our original piece. We've poured a silicone mold, which is now nice and firm, and we're going to peel off the mold board and prepare what we see for the next batch of silicone. So now might be a good chance to zoom in. You know, I think we actually found hot glue that works really well in this stuff. It's taking me forever. Okay, there we go. See, this is what you get. You have the little outline that we made, that perimeter. I'm going to use my same clay tool, and I'm going to clean all the clay out, and then I'm going to put some mold release on just the silicone, because the only thing that silicone sticks to is itself, really. So if I take all the clay off here and we see the part, I don't have to do a thing to the part, because the silicone won't stick to that, but it will stick all day long to itself. And then we won't have a mold, then we just have an interesting block of rubber with our valuable piece inside it, which is no good to us. Okay, so I'm just peeling out the old, this is the clay that we're using to create the locating ring around the outside. I'm sure you remember doing this. And I'm gonna peel the clay out of here. If you're lucky, it all comes out in one big chunk. but it may not. And you will need some patience because you're going to spend some time cleaning up this part. Okay, so I actually pulled this piece out to pull the clay off, and it made it a lot easier. Since this part is not fragile, and it is it molds easily. It came out of a mold, so it's an easy molder. This is not a problem to pull it out and clean it. If you had modified this and it suddenly was fragile, then you really wouldn't want to pull it out of the silicone because it might never go back in the same way, and it might break. So for our purposes today, yes, you can pull these out to clean it. Going forward, if you're doing, like I said, I'll just recap, if you're doing something fragile, you really don't want to pull the thing out. You want to leave it in place as you do the work on it, okay? So while we have it out, I'm going to put the mold release on. Remember I said that the mold, we need to separate, keep the two halves separated, because if we were to pour silicone on this right now, it would lock it up permanently. You'd never be able to get this apart. So I've got a little bit of Vaseline and a little Q-tip, and to get into some of the hard places. All the places where I know there's a hole in there, I'm going to put the Vaseline. Because that will, and I can go a little bit over, it won't hurt anything if I put Vaseline on the entire piece. We just don't need to get that crazy with it. Putting Vaseline, like I said, wherever I know that I can see silicone through the part. And in this case, again, I'll reiterate, I'm also just going a little bit more than that because there's no penalty to it at this stage. Also going to go down the sides a bit. Remember we put the clay down on the sides of it? I just removed that clay, so that's going to be a hollow spot in the mold. And if I don't put clay in there, it will become a solid mess that we'll never open up. You'll hear me repeat this theme throughout the video, because if you don't listen to it, you will be the example that we show everybody on how not to do things. Last year, I think I was the example of how not to do things. Like when it came time to pour the parts, mine didn't pour, and everybody else's did. So I didn't even have Ben to blame it on at that time. So it was a tough day. All right, so I've just done everything I need to inside the mold, right? Just put the Vaseline on the places where I know the silicone from the other half is going to contact. In this case, it's 1, 2, 3, 4, 5. I've done a little bit around the sides. Now I'm going to go around and do everything else. From the edge of the part outward, I have to put Vaseline on. I'm going to use the Q-tip to go into this trench that I've created. And this will create a nice Tupperware snap lock when I'm done. I'll get my little name in there, my name tag. I'll make sure that's all greased up. And we do want to make sure, again, you shouldn't be casual about this. You don't need to put a lot of Vaseline on, but you need to have a little Vaseline exactly everywhere. Or else wherever you don't have the Vaseline, it will stick. So I'm just gonna, for the big parts, I'm just gonna use my finger and go like this, and should be sufficient. But, and again, make sure you've done everything. You might want to do it in a systematic way, where you start in the middle and go outwards, or start on the left and go right, whatever you want to do. Just make sure whichever way you do it, you cover the whole thing. Now I'm starting to see fingerprints, my own fingerprints, in the Vaseline, and that is probably more than enough. Ta-da, did that help? We just turn on the lights, folks. Only at MIT do you get videos of this level. Okay. And I don't want globs of Vaseline. I want enough Vaseline. And how do I know it's enough? Well, at some point I did it wrong. So now I know sort of what's right. You will, by putting on Vaseline at all, first of all, you're way ahead of the game. A lot of people forget this stuff. Okay, so here we go. That's where I am now. I'm ready to put this back in, and it should just pop right in. Okay. Now, I want to free this up. I want to make sure I can move this thing, this piece of rubber. If you see the backside, I only poured halfway through. So what I want to do is pour the second part of the mold in there using this tube as well. So I'm going to, and if you remember the very first time we put Vaseline on the inside, and that is so we can break it loose and push it down to the bottom. We want to be careful not to distort it. You see the parts popping out. That's all right. We'll fix that before we do anything critical. Okay. So take a look. Okay, it's pretty good. Good. Now we'll just leave that alone. Uh-oh. There we go. Okay, so where are we and what are we doing? We are now going to do the exciting part of putting in vents and a pour spout. Now what are those things, Andy? What are you talking about? What I'm talking about is this. When we have a mold, we open the mold, we remove this part. We need a way, when we remove that part, we have a cavity. We need to fill that cavity with our liquid urethane. If we just did it like this, we'd have a very difficult time getting urethane in there without distorting the mold and getting the stuff, the urethane everywhere. It'd be a mess. So what we're going to do is we're going to mold in just a little bit. This is a coffee stirring straw, which is, what do you think that is? 2 millimeters, 2 by 3 maybe, 2 by 2.5 millimeters diameter, of the highest quality, of course. I'm going to put that somewhere right in the middle, like that. And then we're going to use that afterwards. When we have a mold, we're going to be able to pop this out, and we'll still have a hole in that same spot in the top part of the mold we had, the part we haven't poured yet. Okay, so that gets mold making material. Actually, that gets our urethane casting compound into the mold. Great, but it's not going to go anywhere if it's full of air, okay? So we need a way to get the air out. And the way to do that is we use very, very thin stainless steel wire, and we're going to put that on the very topmost edge in several locations all the way around. This is a picky, pain in the butt part, but when done correctly, it means you can get a very good part every time. If done incorrectly, you get a less than stellar part every time, which is why I'm going to teach you how to do it the correct way. All right, so I'm going to cut up this wire into pieces. I don't need to use anything more than that height right there. We're going to, when we pour our mold, we don't need to pour higher than this. So we can come up 20 millimeters. This is perhaps 30 millimeters, and so we just need 30 millimeter high piece of wire, and it's what, 600. It's a foot long, and that's about 600, I think, or 300. I think it's 300. One or the other. So we get 300 out of here. We can theoretically get 10 out of here, but I've already cut it wrong once, so we'll get less than that. And these little pieces are needle sharp, so you will absolutely wear your glasses, and everybody else who's working on the table with you will wear glasses, whether they're doing this or not, because this stuff can fly across several feet and lodge itself in your eyes or in your hair or something. So not optional, you have to wear safety glasses whenever you're doing this stuff. So the way we attach the pipe, the pour spout, the sprue here, the gate, there's several different names. You can call it a gate. We're going to super glue it right in the middle. Super glue isn't really going to stick to this, but it'll hold it strong enough so that we can pour silicone in there. Okay. The way we're going to attach these tiny little things is we're going to heat them up with a lighter and then attempt to press it into the plastic, using the heat of the plastic to melt it. I'm going to try one right now just to see how well it works or whether it doesn't work at all. Red hot, okay, and then we go right into here. And there's one. It's not the strongest thing in the world, so you might find yourself knocking several of these over every time you try to put the next one in. Yes, frustrating, but it's think of it as some sort of therapy to make yourself nice and calm after a long day at MIT. Red hot, and put it in. All right, I'm not going to need to put one every millimeter. I probably don't need to put one every 5 millimeters, but I might do that anyway. 5 millimeters all the way around is a good, I guess, starting point. Some of you might get frustrated and do less, and some of you might find this very relaxing, and you might just put one. You might put twice as many as your neighbor. There is an optimum number, and because we haven't done this part yet, we don't know what the optimum number is. You will find out very quickly if you have not put enough in. You'll get a poor substandard part. Because what will happen is, along this top edge here, we're going to pour the urethane casting material into the mold in this orientation. So the fluid will start, it'll go down here at the bottom of this gate, and it'll spread out into every place that's black now, that cavity, every place where the black stuff is now. It will spread out and it'll move upward, and it will drive the air up towards the topmost edge. If we allow a place for that air to escape on the topmost edge, we have an excellent chance of not getting a bubble in our part. If we, for some reason, don't have enough, or if it's tilted over one way, in a way while you're pouring the stuff in that captures air in the high spot, you'll have a bubble there. You will not have a part in that area, you'll have a bubble. So, with that in mind, I'm going to continue doing this. Okay, so we've got what may be adequate venting. We'll find out later. I started in one corner and sort of moved my way across diagonally, going around this way and starting over this way and doing a couple of high spots in the middle and then the end piece here. If you miss a spot and have to go back in to do it, you'll find that you're going to knock over a whole thing. It's sort of like trying to drop a house right in the middle of a forest. It just doesn't work. You'll knock all the trees down. I tried, you can see that there's something in there that shouldn't be. I tried using super glue to put this in, and the super glue spilled all over the place, and I don't want to take all my little pins out to clean it, so we're going to leave it there, and I'm going to use hot glue instead, and I suggest you do the same. A little drop of hot glue, and I'm going to put it right in the middle of the part. The reason why I don't love hot glue for this is because it leaves a bit of a blob, and that blob can become part of the duplicate part, whereas it's not part of the original, but it'll become part of the duplicate, and you'd have to, if you wanted it to be faithful to the original, you'd have to scrape or grind that piece out, that little blob out, but it's not the end of the world. When you individually need to get to a higher level of mold making, I'll be happy to assist you. And basically, you just need to start, and that's what we're doing today. So, I've got my silicone is all, has mold release, the Vaseline mold release. I removed all the clay. I have put in my vent pins, and I've put in my gate, my straw, my coffee stirrer. right? And I've moved the whole thing down into the pipe so that we have we basically have a self-contained little unit here. We don't need to put another piece of pipe on there. We can just pour straight down. Okay, so the next thing we do is pour more silicone and then pour it into the mold. Okay, I've magically mixed up all the silicone that I'm going to need here. I'm going to, just like we did before when we poured the first side, I'm going to prop up one side on something just so that it's not dead flat. And I'm going to go, and I'm just double checking. Yes, I have put mold release on everything because, believe me, I've done it wrong once, more than once. So I'm going to start at the low parts and I'm going to pour slowly. You see there are bubbles in the silicone that got mixed in, and those tend to sort of pop. If you pour slow enough, those sort of go away as you pour them. When the silicone gets stretched out as it's falling into the cup or into the mold, a lot of the big bubbles go away. Some of the small ones stay, and of course you're making others. The idea is to get rid of as much of them as possible. And I'm going to have to go up a little higher soon to go into the low parts of the mold, the part that the little trench that goes all the way around the outside where we had the clay before. I'm going to put some silicone in there, and yes, it goes all over the wires, and that's okay. It doesn't harm anything. You want to make sure you don't bump the wires so that you don't wind up knocking them over, because once they're gone and you have silicone in there, you've lost that vent. So it's tempting to just dump this stuff in, but I am trying to do it slowly so that I don't get air trapped inside the actual part itself, inside where the cavity is going to be. Uh-oh, there goes one. Just lost one of my vents. Not much I can do except pull it out. I'm just going to reach in there with something. What am I going to use? I'm going to use my Vaseline covered thing. Oh, I've knocked another one over. Okay. That comes out. And this one comes out. If I leave them in, they're likely to get in the way and cause trouble. So once they're removed, we don't have vents in that area, but we also don't have a piece of metal that's going to cause us trouble later. Okay, so now the surface is all covered with its first coat down low, and I'll make sure up high has it as well. I see a bubble. I'm going to go get after that bubble. I'm reminded to tell you that you really shouldn't try to get the bubbles out because you'll knock everything over, and I think I just proved that. In my own haste, I wanted to make it better and probably made it worse. All right, so now I'm just filling it up. I'm going to pull this out, let it go back to being flat and level. I'm pouring around the outside. I never want to dump this right onto the vent pins, because they, as you know, they will fall over. And I don't think I need to go a whole lot thicker than this for the mold. Okay, there we go. The next steps for this are going to be to take it apart, remove the actual part, and then prepare it for pouring a urethane part.